calculating the rate for the forward reaction, that will become rate of forward reaction. If I'm calculating the rate for backward reaction, that will become rate of backward reaction. Now let us suppose we're having a graph like this. Let us suppose we're having a graph. On this side you're having rate, on this side you're having time. So initially the concentration of A will be maximum, so rate of forward reaction will be maximum and it will decrease like this, and the rate of backward reaction, that will be like this. You're getting my point? Sorry, I made a mistake. The rate of forward reaction will be something like this, and the rate of backward reaction will be something like this. Now this is our rate for forward reaction, this is rate for backward reaction, and what we can observe that at this time t, the rate of forward reaction is equal to what? The rate of backward reaction. And the time at which the rate of forward reaction is equal to rate of backward reaction is what? It is the time taken to attain the equilibrium. And this state is known as what? This state is our equilibrium state. This state is our equilibrium state, because what we know that in case of equilibrium both the opposing forces will be equal. In this case the two opposing forces are RF and RB, so RF and RB has to be equal. So this point is representing the equilibrium condition, and the time at which this state is attained is the time taken to attain the equilibrium. Now we can also use catalyst in this reaction. Now what we know, catalysts are of two types. It can be positive catalyst or negative catalyst. What is difference? So positive catalyst is that catalyst which decreases the rate of reaction, and a negative catalyst is that catalyst which increases the rate of reaction. So if I'm having a positive catalyst, what we'll observe that there will be decrease in the rate of reaction. An important point is that the decrease in the rate of reaction will be observed for both forward and backward reaction. And the equilibrium state, the very important point, that the equilibrium state is not affected. The equilibrium state is not affected means it will remain as it is. Only the time taking to attain equilibrium, that is decreased in case of positive catalyst. And if I'm having a negative catalyst, so negative catalyst will decrease the rate of reaction, means the time taken to attain equilibrium will be more, and the equilibrium state will not be affected, means equilibrium state will be as it is. So this is our negative catalyst. So blue line is representing positive catalyst, white line is representing no catalyst, and green line is representing negative catalyst. You can observe that equilibrium state is unaffected, only change is the time taken to attain the equilibrium. This graph was drawn between rate of reaction, rate of forward reaction, rate of backward reaction, and time taken. The next graph which we'll see, that will be concentration versus time graph. That will be concentration versus time graph. This side I'm having concentration, this side I'm having time. Now for reactant, what we can say, that with the passage of time the concentration of reactant will decrease. So this is representing the concentration of reactant. And for product, what we can say, that with the passage of time the concentration of product will increase. So this is representing for the product. This line is for the reactant and this one is for product. And what we know, that rate is equal to delta concentration upon delta T. That is change in concentration upon change in time. That is our rate of reaction. Means if I'm considering for very small time interval, we can say that rate is dC upon dt, where C represents concentration, T represents time. So dC upon dt is nothing but the slope of the curve which is drawn between concentration and time. Means if I'm drawing a tangent at any point, the slope of that tangent will give me what? Will give me the rate of that particular reaction. Is this point clear or not? If I'm drawing a tangent at any point, the slope of that tangent will give me the rate of reaction at that particular instant of time. Now let us suppose we're having 4 time intervals. This is A, this is B, let us suppose this is C, and let us suppose this is D. Now one very important question is that at which time equilibrium is attained? At which time equilibrium is attained? So many of you, I'm sure many of you might be thinking that B is the time at which the equilibrium is attained, but that's not the correct answer. Correct answer is D, that D is the time at which equilibrium is attained. What mistake you made? The mistake is that you thought the equilibrium is that time, or time taken to attain equilibrium will be the time at which the rate of forward reaction is equal to rate of backward reaction. But at this point B, the rate of forward is not equal to rate of backward reaction. At this point B, the concentration of reactant and concentration of product is equal. If I want to find rate के लिए we have to draw a tangent at this point, and what we can observe that the tangent at this point, it will have different slope, and if slope of the tangent is different, it means they are having different rate of reaction. But if you are drawing a tangent at point D, what you'll observe that the slope of both the curves is same, and the slope for both the curve is same, means both the curves are having same rate. One is for forward, one is for backward. So rate of forward is equal to rate of backward at time t. So this time is the time taken to attain equilibrium, and the corresponding concentration of the reactant and product will be the equilibrium concentration of the reactant and the product. Are you clear with this point? So this point just keep in mind. So till now what we have discussed, what is the meaning of equilibrium. Then we have tried to understand what is reversible reaction and what is irreversible reaction. After that we have tried to find the rate of reaction. What will be rate of reaction if stoichiometric coefficient is 1? If what will be the rate of reaction if we are having different stoichiometric coefficient? We have solved one question on rate of reaction, and we have seen two graphs. One will be rate versus time graph, second was between concentration and time graph, and till now we have had basic idea what actually equilibrium is.